Left off in the previous video with a discussion of error. And error is just the difference between the data that is observed and the forecast that you made. And we talked about two potential sources of error. One is an error that is just inaccurate, and the other is an error that's imprecise. And both of these are errors, but they may have some different implications for your business with respect to how you make decisions. So making a large number of inaccurate forecasts that are fairly precise, fairly close, but they're still inaccurate may be viewed differently than making a ton of accurate forecasts, but one really, really imprecise forecast. And so we're sort of seeing the implications even today of making imprecise forecasts. We may have understated the magnitude of the current pandemic by several orders of magnitude. And that's a significant problem that we could have. So if we take a look at these different types of error, we have mean absolute percentage error, which we take the error divided by the data. That's the percentage error. We make all of these percent errors positive, and then we just take the average. We have the mean squared error, where we just square errors and average them together, and we have the root mean squared error. And the mean squared error is the preferred mechanism for evaluating the quality of the forecast. So the squared error both keeps track of inaccurate forecasts. We're going to use all the errors, but it also penalizes highly imprecise forecasts. It squares the errors of those forecasts, making them look even larger. And so when we went over the slides associated with ExxonMobil, you can see that the squared error really penalizes this error for January 8. The forecast error was minus 1.06. We were off by $1. We square it, it's even larger. But if you look at the relative differences of magnitude between the forecast error and the forecast error squared, here the forecast error is about double the average of the previous ones, but then the forecast error squared is about triple the average of the others. And so we're going to continue to use the squared error and root mean squared error as our primary tools to evaluate the quality of the forecast, much as we use the squared residuals to help us evaluate the quality of the regression. So the further away our forecasts are from the data, the worse we think a particular forecasting method is. With regression, the further away the data points were from the line, we start to think the line doesn't describe the data very well. With forecasting, if we have large squared errors, we might want to try to choose another method. So with regression, there's only one way to fit a line through data, and we're just trying to evaluate whether the line plausibly captures a relationship between x and y. But with forecasting, we have a bunch of different ways to model y, and we're just trying to model y from previous y. We're not including any x, at least not in this class. So if you take a forecasting class that's just purely dedicated to forecasting, like the one we're offering in the fall, we're going to look at some methods where we have previous values of x and previous values of y to forecast y, but not in this class. Okay, so prior to our worlds being thrown upside down, we could think of our purchases at Starbucks. So I went to Starbucks almost every day. I didn't always buy the same thing. Sometimes I would buy a chai tea latte. Other times I would get a latte. Most frequently I would just get coffee. Sometimes I would get something to eat with the coffee, maybe a bagel or a cookie, something like that. But my total, sales price would vary over days. And random chance may dictate what I buy. So you walk in, it's cold outside, you feel, hey, I need something extra. Maybe you get a bigger size. Or you're just trying to get something quick between class, maybe you get a cookie. Random chance may vary the price of the items that you buy. So when you go to pay at the register, that may be completely contingent on how you felt in that particular moment. If I just rely on the previous day, I'm assuming that every day going forward is just like yesterday, but clearly that's not going to be the case. So I may have wild swings in purchases from day to day, and the naive model will always be behind there. And you can see this very, very precisely with the sales data from the Gap, but you would also see this in, say, your Starbucks purchases. And so what we like to do in these instances is smooth out the forecast. So I understand that some days I may spend 263, other days I may spend 785, and I may want to make a forecast that's in the 5 range. And the easiest way to do this is with what's called a moving average forecast. A good example of when we want to smooth out some data points happened when I was in high school, actually, September 11th. So September 11th happened, and in October 2001, flights were disproportionately low. But slowly over time, people became more comfortable with flying again. Nonetheless, if we just use October to forecast November, we're going to have a really, really disproportionately low forecast for November. But we may also want to include some of the wariness that people felt about flying for many periods to come. We can do this with what's called a moving average forecast. So my forecast for period T today is an average of previous time periods. So an example of a one period moving average is the naive model. 100% of my forecast comes from yesterday. That may not be sufficient. I may want to include some data that is from periods prior to yesterday. I may not just want to include one period of data, which is what we would be doing with a naive or a modified naive forecast. So for a 2-period moving average, I include data from yesterday, like the naive, but I also include data from 2 periods ago. That's different from the naive. So unlike the naive and modified naive models, now we're starting to incorporate multiple pieces of information in our forecast. Take a look at the formula at the bottom of this slide. YT hat is equal to YT minus 1 plus YT minus 2 hat divided by 2. What we're doing with the moving average forecast, where the smoothing occurs, is we split up the forecast in half. Half of the forecast comes from the immediate previous period, and that's T minus 1. Half of the forecast comes from 2 periods ago, and that's T minus 2. So the moving average forecast is a weighted average where every weight is the same. Now, if you go to the 3-period moving average forecast, you have YT minus 1, that's yesterday, YT minus 2, that's 2 days ago, and YT minus 3, that's 3 days ago, and we split it in thirds. So if you think of a pie, cut it into 3 equal slices. All periods are equally weighted for a moving average. So a 5-period moving average has 1/5, 20% of each of the previous 5 periods. And this may or may not be desirable. So we might think that the more recent past is a better predictor of the future than the more distant past. We'll get into methods that account for this, such as exponential smoothing. But right now we're just looking at something where all periods count the same. And you could think of this as being forecasting sales on a Tuesday. So what are Jimmy John's sales on Tuesday look like? Well, there's probably not a lot of trend up or trend down in Jimmy John's sales on Tuesdays. So we could easily think of using a moving average to calculate what sales will be next Tuesday based on the previous Tuesdays. So you can also do some stuff like modify the moving average to only include relevant periods from the past. So if I wanted to take an average temperature for April, what I could do is use the previous April. That's a modified naive, but I could also average together a bunch of previous Aprils, and that would be kind of a combination of the modified naive and the moving average. And the nice thing about forecasting is that you're actually allowed to do that. So I don't want to say that there's no right or wrong way to make a forecast. We have better ways, and those have lower root mean squared errors. but you are allowed plenty of flexibility in how you make a forecast. So forecasting is really flexible, and that's kind of neat. All right, so let's take a look at a timeline for a 2-period moving average. Let's pretend we're making a forecast at time t minus 1. We cannot make a forecast at time t minus 1 without observing time t minus 3. We can't do a 2-period moving average. So I put this in red for a reason. Let's pretend that time starts at t minus 2, and I try to make a forecast at t minus 1 using the 2-period moving average. I can't do it. I only have one period I need to. Okay, so I cannot make a forecast. I just have to skip that period. In fact, the only forecast that I can make is a naive forecast. But when I go to time t, now I've observed yt minus 2 and yt minus 1. I actually have the green light to go ahead and forecast for time t based on 2 previous periods. And I can do this going forward, replacing the period that's 3 periods ago with the period that's immediately happened in the past. Now with the 3-period moving average, let's say time again starts at t minus 1. I can't make, or t minus 2, I'm sorry. I cannot make a 3-period moving average forecast for t minus 1. So I can't forecast yt minus 1 hat with a 3-period moving average, nor can I forecast yt hat with a 3-period moving average. I can go back and do a 2-period moving average, but I can't do a 3-period moving average. The first time I can start to do a 3-period moving average is in time t plus 1. Okay, and so I demonstrate that here with just some recent NASDAQ data. This is over the past 2 weeks. And you can see the close price for the NASDAQ over here. Okay, and it's listed right here in the second column. Now I show you the naive forecast, and the forecast for March 20th is March 19th, and the forecast for March 23rd is March 20th, etc. And we're skipping the weekends because they don't trade on weekends. I cannot make a 2-period moving average forecast if I assume that this is the first data that I observe is in the 19th. I can't make a 2-period moving average forecast until March 23rd, where I average together March 19 and March 20th. I can't make a 3-period moving average forecast until March 24th, where I average together March 19th, March 20th, and March 23rd. And I can't do a 4-period until March 25th, when I average together the previous 4 periods. And you can see this on the next slide. So the naive forecast for March 25th was March 24th. The 2-period, I averaged together March 24, that was yt minus 1 on March 25th, and March 23rd, which was yt minus 2. So to get a 2-period forecast for March 25, I averaged together March 23rd and March 24th. And I do the same thing for March 26th and 27th and 28th. I just replace the periods that are further in the past. Now for the 3-period moving average, I average together March 20, March 23rd, and March 24th. Okay, so I go back 3 periods here. I average together the 24th, the 74.1786, the 23rd, the 6860.67, and the 20th, the 6879.52, and that's how I get this March 25th, 7052.683. Now to get the 4-period, I average together all 4 periods here. And you can see that I do this here actually for the gap data. So if I took a 3-period average, this is what the averages would look like. And if I do 4 periods, this is what the averages would look like. And I can't make 3-period forecasts for quarter 1, quarter 2, or quarter 3. I have to start in quarter 4, and I can't do it at all for any of year 2000. I have to start in year 2001. Now you can do a moving average forecast in Excel, and let me show you how it works with this NASDAQ data. So we're in Excel now. I'm in the column B here has the data. Column C, I made a naive forecast. Let's take a look at column D, where I want to do a 2-period moving average forecast. How does it work? Can I make a forecast for March 19th? No. Can I make a forecast for March 20th? No. Can I make a forecast for March 23rd? Yes. It's the average. Type in equal average and click the data that you want. These 2 periods. And that is the same as the information that's listed here on this slide. Now you can make all the forecasts in the same way. You just copy down the column. How do I do the 3 period? Can I make a forecast for the 19th? No. How about the 20th? No. How about the 23rd? No. How about the 24th? Yes. You type in equal average. You just click the data that you want. Now you can set it up as a set of data with a colon, B2 to B4, and just hit enter. And I get the 6963.59 that is listed right here. Now for the 4 period moving average, I again can't make a forecast for the 19th, the 20th, the 23rd, or the 24th, but I can for the 25th, and I'll do that here. B2 to B5. So to summarize, for the 2 period, I have 2 periods. For the 3 period, you have 3 periods. For the 4 period, you have 4 periods. How do we find the error? Can I find an error for 19th for the 2 period moving average? No, I can't do it. How about the 20th? No. How about the 23rd? Yes. The error, I take the data and I subtract the forecast. Those are the errors. You can see sometimes I miss up, sometimes I miss down. How about for the 3 period? Can I calculate an error for the 19th? No, I didn't make a forecast. How about the 20th? No, I didn't make a forecast. How about the 23rd? Sure didn't make a forecast. What about the 24th? Yes. Data, column B, minus forecast, column E. And you can see I color-coded these to kind of help us out here. Now, let's say I want to evaluate which forecast is better between the 2 period and the 3 period. I can calculate the squared error. You take the error that's in column G here, and you just square it. And you just copy it down. So you see I took the error and I squared it. And I did that for all the forecasts. And you can see the forecast that really contributes the most to the squared error is the forecast that was made on the 24th, where the market went up quite a bit on the 24th. And this was kind of when the stimulus was starting to be announced. Now, for the 3 period, data, which is located here in column B, minus the forecast is what created the error. And when I square the error, I just square the error. How do I find the mean squared error? You can take the average of the squared errors. I can only take the average of where I made squared errors. What is the root mean squared error? You just take the square root. It seems like the 2 period does a little better now. If we were to maybe delete this squared error, you could see that it gets a little bit closer if we just evaluate the 2 methods for the periods that we made forecasts. But in general, it seems like the 2 period does a better job. So I can make a note of it. I can say it has the lowest root mean squared error, better quality forecast. Why is it better? We miss by lower amounts. Every forecast miss, we miss by lower amounts. Excel will do this for you. If you use the data analysis tool pack in Excel, I go to data, data analysis. Excel actually has a built-in moving average forecast for you. Now, the trick with Excel, if we go back to the slides here, is when you put the input range is the data. The interval describes how many periods you want to put in the average. So we go back to Excel, I hit moving average. Input range is the data. interval is how many periods you want in the moving average. The output range, this is really important. You want to start it one row lower than your first data point. If you don't do that, it will incorporate the current period in the forecast for the current period, which you already know what the data for the current period is. And here I show you just what would work with the gap data that we see on this previous slide, how to do it in Excel. And you can look at the screenshots for that. Now, what does a moving average forecast actually do? You can look at the blue line, and those are the sales for the gap. And if you look at the red and the green lines, they just really make flatter forecasts. That's the goal of the moving average. And so if we were to actually go back to our data within Excel, here's the close price for the stocks. And if I take these two, actually let's take these three, and we make just a line chart here. Let's see if this works. You can see that the over the periods where we observe the data, the closing price is very volatile here at the blue line, but the average is much smoother. And that is the goal of the moving average forecast. We'll delete this chart here. Just a few facts about the moving average models. A naive model is a one-period moving average. These models don't predict peaks and troughs very well. They're specifically designed not to do that. They are useful if we do not think there are huge deviations from period to period, but we want to kind of smooth out idiosyncratic behavior. Nonetheless, we don't have to make a value judgment based on a picture. We just use the root mean squared error.